Hey guys, so I want to give you slopes, which is section 3.1. So I'm going to do that by example a little bit. The idea here is I've got some function, f of x is 3x plus 2. Now you might notice that this is what I've been kind of calling a line, right? Like there's an x with one power and then there's maybe some multiplication, maybe addition of numbers, but otherwise really there's just a 1x, right? So if we thought about graphing this thing, I think you guys are all pretty on board with the idea of making a table, x and f of x, right? And then we'll plug some x values in. And for the purposes of this, I'm just going to plug in a couple, like my favorite, 0, 1, and 2. So if I plug 0 in, I get 2 out. Oh, actually, that's worth noting, right? When I plug 0 in, I got 2 out. That means that this thing is the which intercept? I think that's the y-intercept right there. Right? See that? It's just written right on the end. It's the number you're adding after you do your stuff with your x's, right? Okay. If I put 1 in there, I get, let's see, 3 plus 2 out, which is 5, of course, but I'm illustrating right now that what I did was I added 3 to 2. So I took the y-intercept and I added 3 to it. When I do 2, right, when I do f of 2, I'm getting 3 times 2 plus 2, which is 8, which is, maybe notice, 3 more, right? So every time I go 1 down on this side, that's adding 1 on this side. Adding 1 over here corresponds to adding 3 over there. And that kind of makes sense, right? Because I'm multiplying that thing by 3. So if I add 1 over here, then I end up adding 1 multiplied by 3. 3 on the other side. Cool? So if I draw this thing, I go up 2, put a dot, I go over 1, up 5, put a dot, and here's my line. And I might notice, hey, that kind of over some, up some looks pretty consistent, right? Like, here's my little, that's my like over 1, up 3 triangle that happened in between these 2 points. But if I went from, say, my y-intercept over to the other point that I graphed, right? That's going to be over 2 things, and then up how many? Oops, things off a little bit. I think that's going to be over 2 and up 6. And if I thought about 6 over 2, that's the same thing as 3 over 1, right? So this slope here, that's really what this guy is, right? Because see, it's consistent, so we're gonna, and it's kind of telling you how slanted the line is. So I'm going to call that slope. And the thing that I want to know about slope is that slope is rise over run. You guys see that? 3 over 1 or 6 over 2 or whatever. It's the change in the y values divided by the change in the x values. And that's actually a nice, easy way to remember that. That's change in y's over change in x's. Yeah. This symbol just means change in. It's kind of a funky thing. Let's see, what else should we know? I think this gives me a nice, easy way of recognizing lines. So when I've got one of those lines, a line as f of x is mx plus b, I think now this gives me words for m and b. M's the slope, right? Which is the rise over the run. And b is the y-intercept. So it should come as no surprise that this whole form right here is called, don't think too hard, slope-intercept form. Intercept. Cool. So this is what I want you to know about lines for right now. Another thing I should tell you about lines is that if I knew, for instance, 2 points and wanted to calculate the slope, that I could do that, right? So if I had 2 points, like this, right? This one's got some coordinates, like maybe x1, y1, and this one's got some coordinates x2, y2. Well, I want to know this height, right? That's the change in the y's. So that's the high y, y2, minus the low y, y1. And then these guys, the change in x's, that's the, let's see, the first x. I started with y2 here, so I have to start with x2 there. And I should subtract x1. So my slope for this guy, right, is y2 minus y1 over x2 minus x1. And see, that's change in y's over change in x's. Cool? So for instance, if we did that with the points I had fiddled with over here, right, this point is 2, 8. This point here is 0, 2. Right, so I'd run that as, okay, the slope here is, take the y over here, 8, subtract 2, divide by 2, subtract 0. And if I figure that out, I think I've got 6 over 2, which is this 6 and that 2, which gives me this 3 right here. Cool? It might be worth noting that slopes don't always have to go up, right? Lines could go down. If the line goes down, what do you think about the slope? I'm hoping you see that if I go over and then the slope's positive, I'm going to go up. If I go over and the slope's negative, I should probably go down, right? So rise might be negative, and that's okay.